Okay, so this is a problem which we want to solve. We have two aircraft as in a figure, aircraft A and aircraft B, and the magnitude of the velocity is given for both the aircraft. We want to find the velocity of B with respect to A. That's what we want to find. Okay, so basically VBA means we want velocity of B, again vector, minus A. So you can do this using vector method as well as the graphical method. So we'll start with the vector methods. My recommendation is to make use of the vector method. This is a little bit tricky, but vector method is kind of straightforward. Okay, so in vector method, what you do is you break the vector into its component. For instance, here you have VB like this, okay, and the angle it makes is 60°. Okay, so this is VB. Now you need to break this into X and Y component. So this is in unit vector I, this is positive J. So you could write this, remember this direction is important. So if you do that, it would be VB cosine 60, and it would be downward VB sine 60. So you can write VB as a vector into component, which is the negative I direction. So you have minus VB cosine 60 I, okay, and then in the J direction the component is also negative, so you have minus VB sine 60J. So this is what you have. You put the value, this is what you get. Okay, now this is for VB. Now for VA, it is moving towards the right, and based on our sign convention, so this is our sign convention, towards the right is considered to be positive. So again, write in terms of IJ, so it would be 650 I. Okay, now we know VA, we know VB. Now we want to find out BVA. Again, this is a vector which is VB minus VA. So put this value. So VB is minus 800 cosine 60 I, and then minus 800 sine 60J, and then this minus comes from the formula. Remember this, and then VA is 650 I. Now you need to add together the term with, you know, I term. You can add this together with, and then if there was another J term, then you could do similarly. So in this case you have two I term, and if you do the math, so if you add together, this is what you get. So you have a VBA whose I component is, I component is in negative direction 1050, and then the Y component is 692.8, right? Now in order to find the resultant, so you can use the rectangle law. So this whole square plus this whole square would give you the resultant. So this is the magnitude of velocity of B with respect to A, and in order to find the direction, so basically we are trying to find what this makes with the horizontal. So the ratio of Y component divided by the ratio of X component, that's tan theta. So tan theta would be tan inverse this, so the angle is 32.4. So this is how we can find the velocity of B with respect to A using the vector method. So the process is for each velocity, or you just break into IJ component, and then put it into the equation, do the manipulation based on the sign, and then find the resultant using the rectangle law. And since you know X and Y component, you can find the direction as well. So that's the way to do it. And remember, this equation, so this always forms a triangle. So it's like, so in this case you need to figure out, so in this case BV is summation of VA plus VBA. So you need to have this is equal to this. So you need to figure out the way by which you have this triangle if you want to use the graphical method. For instance, so VB is something like this in this direction, and VA is going in this direction, and if you put this like this, so this should be VBA. So this is VA, so VA plus VBA would be VB. So this is in the same direction and this is in opposite direction. This is like a resultant. So this is what we will be using for the graphical method, which makes use of sine law and cosine law. See, if this angle is 60, the whole has to be 180 degrees. So this only this angle has to be 120 degrees. So this angle is important to us. Okay. So if you know that, so this is what it is. So it always forms a triangle because these are all vector, and so this is the resultant. I did based on this. Everything is, we cannot change this angle, right? And this is 60. This has to be 180. So this VA plus VBA has to be VB, and this angle is 120. And also we know VA is given, VB is given. We need to find out this one, right? And then this angle is given. So if you use the cosine law, this whole square, see, this whole square is a square plus b square. So c square is something like, c square is a square plus b square minus AB, and then cosine whatever the angle is. So you want to find this angle, so this 120 is given. So we can find out what that magnitude for VBA is. So we use the cosine law. And if you want to if you want to find, this is the resultant VBA, and we want to know what angle it makes, now use the sine law to find the angle. So this is the angle which we are interested in, right? Because this is the angle, the VBA mixed with the horizontal, and that's what we are interested in, right? So VBA is known, so this is what we calculate. This angle is known, and then we are interested in this, so we have to know this is VB. So VB by sine 120, so this is from sine law, and then VB by this sine theta, the VBA mixed with the horizontal. This is the angle which you are interested in. So the only unknown here is sine theta, which you can calculate, and you got the same answer from both process. So this is another way of solving. Is a little bit geometrical, a little bit complicated. It's not very straightforward like the previous method, but this is one of the other way by which you can solve this kind of problem. But I would always recommend to do the problem using the vector method.